In this video, we're going to look at finding parametric equations for the path of a particle that moves along a certain Cartesian graph, given some restrictions on how we want that path to be created, how that particle is moving along the path. So here we're interested in finding parametric equations for the path of the particle that's moving along the graph. X minus 1 squared over 9 plus y plus 2 squared over 4 is equal to 1. So the first thing we want to just think about is, what is this here the graph of? And this is where our review of the conic sections comes in helpful. This is an ellipse that's centered at 1, -2, okay, where I have a is equal to 3 and b is equal to 2. So just to get a quick sketch of what this entire graph would look like, let's see, we're centered at 1, -2, okay. I would move out 3 units horizontally to get to my horizontal vertices, and 2 units vertically to get to those vertical vertices here. Okay, so this just gives me a rough sketch of my ellipse. So now I'm talking about how, let's see, can I do a slightly better sketch here? We want to talk about how this curve, or a portion of this curve, could be traced out with some different parameterizations. So the first one's saying I want to try to trace this curve out in the clockwise direction, starting at the point 1, 0. Okay, so starting at the top point here. So a couple things to think about. When we graphed circles, we had been given x was equal to something in sine and y was equal to something in cosine, and then created the graph of our circle by using that sine squared plus cosine squared was equal to 1. Here I can do something similar, but working backwards. So if I know that sine squared plus cosine squared is equal to 1, I could let x minus 1 over 3, okay, because that quantity squared would then be sine squared, be equal to sine t, and y plus 2 over 2 be equal to cosine t. Okay, so sine squared t plus cosine squared t would equal 1, or in other words, x minus 1 over 3 squared plus y plus 2 over 2 squared would be equal to 1. That would be the equation that we started with. And I'm choosing to have the x part here be sine and the y part be cosine, because we remember in our previous example, we got a clockwise direction from having x be the sine component and y be the cosine component. Okay, so notice that this makes x equal to 3 sine t plus 1, and y equal to 2 cosine t minus 2. Okay, so now the question is, what should our restriction on t be to have us start at the point 1, 0, okay, and go around the entire ellipse. So here we'll start by just making a table of some values and sort of see where that takes us. So we'll just start with t equals 0. So if I plug in t equals 0, notice that I would get x is 1, and when I plug in 0 here for t and 2 cosine t minus 2, we know cosine of 0 is 1, so I'd have 2 minus 2 is 0. So it looks like that actually gives me that point of 1, 0 where I'd like to start. So we'll go ahead and plug in a couple more values, just picking some nice easy values of t to use. So we'll say we'll do pi over 2, pi, 3 pi over 2, and then 2 pi, okay, and see if this gets us all the way around the circle. So when t is pi over 2, notice that x will be equal to 4, y will be -2. When t is pi, I'll have x is 1. Okay, remember if I plug in pi here for a cosine for t and cosine of pi is -1, so that would be -2 minus -2, I'd have -4. I plug in 3 pi over 2, I'm going to get the point -2, -2. We plug in 2 pi, we're going to get back to 1, 0. Okay, back to where we started. So it looks like I can get the whole ellipse by having by having t range between 0 and 2 pi. Okay, so let's go ahead and do our sketch here. So t is 0, I'm at the point 1, 0. So right here at t equals 0. At t equals pi over 2, we're at the point 4, negative 2. Let's see, x is 4. So we have 1, 2, 3, 4, negative 2. So we're down here. At pi, I'm at the point 1, negative 4. Okay, so this is getting us some of our vertices. Whoops. At our 3 pi over 2, we're at negative 2, negative 2. Okay, and then back at t equals 2 pi, we're back to where we started. Okay, so this was t equals 0, pi over 2, pi, and 3 pi over 2. And it was being traced out clockwise because I started up here. So let me just make my ellipse here, okay, where my arrows are going to look something like this, okay, showing that I am going in that clockwise direction. Okay, so what's going to change in part B here? So in B, I want to go 3 times around the ellipse in the counterclockwise direction, and I want to start at the point 1, 0. So the fact that it's counterclockwise means I'm going to want x to be that cosine component and y to be the sine component. So here we can let x minus 1 over 3 be cosine of t, and y plus 2 over 2 be sine of t. So I'm still going to have sine squared plus cosine squared is 1. So this x minus 1 over 3 squared plus y plus 2 over 2 squared will still be 1, still be the same thing that we started with. I'll have x is 3 cosine t plus 1, and y is 2 sine t minus 2. Okay, now here I said I wanted to go 3 times around my ellipse. So let's just look at plotting a few values here. Okay, so again, I'll just start at 0. Okay. So if I plug in, 0, I'll get 4, negative 2, okay, because I'll have cosine of 0 is 1, 3 plus 1 will be 4, sine of 0 is 0, so we get negative 2 here. Then I could plug in pi over 2. Okay, notice that cosine of pi over 2 is 0, so I get 1 here. Sine of pi over 2 is 1, so this will be 0. And we did actually want to be starting at 1, 0, so that's a good sign there. Let's see. So let me just go ahead and plug in pi. If I'm at pi, I'll be at the point negative 2, negative 2. Okay, so let's just get an idea of what this is giving us. So notice that at pi over 2, that's when I'm going to be at this point 1, 0. What I've already shown in the previous problem here is that I can go around my ellipse once with this period of 2 pi. So here I'm going to want t to range from pi over 2. I want to go around 3 times, so I want to do pi over 2 plus 3 times 2 pi. Okay, so I want t here to be pi over 2 plus 6 pi, which will end up being 13 pi over 2. Okay, so I can write that simplified over here. T is between pi over 2, pi over 2 and 13 pi over 2. Okay, but the idea is that I have these same vertices. This is still my same ellipse. We're just tracing it out, in this case, going around it 3 times. Okay, so this is here at t equals pi over 2, we're at the top. Okay, I'm going in a counterclockwise direction. Notice that at pi, I'm over here at the point negative 2, 2, and that direction is going to continue, so I'm going to go this way. Okay, that would be pi over 2 plus 2 pi. I'll go around again for another 2 pi, and around a third time for another 2 pi. Okay, so I'll just circle this part here for giving us our ellipse in the counterclockwise direction and going around 3 times. Okay, so there was one other variation we wanted to look at. Halfway around, but going counterclockwise. Okay, so I'm going to erase our initial sketch of the ellipse. We've drawn the ellipse several more times here. This is saying still counterclockwise, so it's going to be the same equations that we just had in B. So I'm going to have x is 3 cosine t plus 1. And y, whoops, this is 3 cosine t plus 1. And y is equal to 2 sine t minus 2. Okay, and now I wanted to start at 4, negative 2. Okay, well, let's see, 4, negative 2 was over here, and 4, negative 2, it looks corresponds to a t equals 0. Okay, so I can have my t for starting at 4, negative 2 here start at 0, and I want to go around just halfway, so I want to go from 0 all the way to pi. So I'll say t is between 0 and pi. Okay, so that gives us the ellipse going from here to here in that counterclockwise direction. Okay, so this just gives you something to think about in terms of going the other way, thinking about how to choose your parametric equation so you can trace out the path in the particular order and direction that you would like it to be traced out. So let me know if you have any questions on this.